loud and clear.
Okay, so this first tutorial is just going to be the pre-launch procedures. I've sort of adjusted the lighting just a bit here. I can't, kind of hard to get over how everything looks foggy in this cockpit, but I'll try my best here. So the procedure is obviously we're assuming you're down at T-minus 25 minutes. So you'll run all the way down here. You'll run the launch preparations. And that's going to start with program 1. Program 1 is going to load that launch refs mat, and it's going to torque the IMU to that launch pitch, as well as the launch azimuth on roll. So we can see the no attitude light is on right now, signifying that the IMU is in course align mode and that it cannot be used as attitude reference. Once the alignment is complete, the no attitude light will turn off and program 2 will start. Program 2 serves as a gyro compassing program. So as Earth rotates, the IMU would actually drift significantly. To prevent this, we activate certain systems which are able to measure the gravity and keep the IMU basically relative to the gravitational field, so it can subtract at Earth's rotation properly. And that's what program 2 does. It gyro compasses the IMU. Here, we'll activate each individual thruster on the auto RCS select. So we'll tie them to the main buses. And this is in case of abort. We don't actually use RCS during the launch at all. However, if we were to abort, we would need the RCS if we were above mode 1 Charlie. When you do reach that T-minus 15-minute mark, you're going to go ahead and read out battery C. And you're just going to verify that it's got basically greater than 37 volts, equal to or greater than 37 volts. And that's good. Back to main A. Battery C is a backup. If you flip on the main bus ties, you won't draw from battery C unless you plug in the circuit breakers for those. FDAI scale. This switch sets the scale on the FDAI. So if we were to have any rates, basically our rates would display right now on 5.1. That means that every 5 ticks is 1 degree per second. On 5.5, that means every 5 ticks is 5 degrees per second. So basically each tick is worth 1 degree per second. This one, every tick is worth 0.2 degrees per second. And on 50.15, it's every 50 ticks is 15 degrees per second. And that's kind of confusing to understand. You're never really going to navigate in 50.15, so that's hard to math out, and I never use it. So yeah, so rotational control power, your normal is basically auto, and your direct is your direct coils. So when you're moving the hand controller, you fire the normal coils if the controller is not all the way pushed in one direction. And you fire the direct coils if it is all the way pushed in one direction. This does mean, of course, that if you're flying on keyboard and mouse, you are always using the direct coils, even if you have them turned off like so. Just because of the way that, you know, keyboard and mouse has to translate into the game. But if you have a joystick, this does indeed work. Direct coils will fire more impulse out of the jets than the auto coils will. BMAGs, these are your body-mounted attitude gyros. And moving it from rate 2 to rate 1 just basically selects which BMAG will be measuring rates. We'll talk about at 1, rate 2 later. But just for now, just know that the difference between these is actually simply just changing it from gyro 2 to gyro 1. And this serves the purpose of measuring your rates and displaying on these needles here. And it also serves the purpose of keeping your gyro display coupler attitude reference, basically. So the BMAGs will measure and compute the attitude for the gyro display coupler. Then we've got ourselves a comms test. You would click that off, perform radio check, and then click the 2 back on. Next up is the EDS. This is the Emergency Detection System. With that on, we can see we do get no auto abort. Or sorry, we do get the auto abort. The no auto abort light turns off. So we will get automatic abort. And what that means is basically the system will detect if there's 2 engines or more that shut down, you will abort. If the rates in one direction, which is actually aided in the launch vehicle angle of attack indicator here, if those rates exceed a certain amount, you will automatically abort. And if the angle of attack exceeds a certain amount, you will automatically abort. With EDS auto to off, you set the emergency detection system to manual. And at that point, the abort system can only be controlled with the THC here by twisting it. That's not simulated in reentry. The twisting, this Control-Shift-Z is how you would activate the abort. This right here, RCS command, yeah, flipping that to off just prevents RCS fire. Thrust vector control servos allow the gimbal motors to run. So these thrust vector control servos inform the gimbal motors. Basically, it's motors telling motors what to do. So these servos will measure torque and then output that response to the gimbal motors. And the gimbal motors will input the opposite torque into the gimbaling of that SPS engine and drive the attitude. So motors telling motors what to do. Fuel cell react valves, normal latch. This switch latches the fuel cells in whatever position they're in. So if it's closed, it will latch the fuel cell valves closed. If it's open, it will latch the fuel cell valves open. This is because it's assumed that the vibration from launch and staging, or the separation from the S4B and that staging, imparts such vibrations that the valves can actually shock open or closed. So that switch, bam, keeps them all open, since they're all open right now. Prevents them from being closed. The secondary coolant loop is already off, so you can bypass that step. At 4 minutes, 10 seconds, you're going to get the engine interface on the emergency detection system, and you'll get those lights up as the Saturn comes to life, basically, and it starts giving you data through the umbilical, riding up the side of the craft into the capsule. These lights will turn on, signifying that there is engine out or ignition failure. So basically, these lights on is bad. However, we haven't ignited the engines yet, so it's actually good.
Program 2. All right, CMP on panel 2, insert verb 75 and do not enter.
Verb 75.
Verb 75, standing by.
If program 11 were not to run when the umbilicals are retracted, program 11 is set to automatically run. So there's like a final signal that just gets sent to the rocket via the umbilical, and then the umbilical retracts. And if for whatever reason that signal doesn't come to the computer by the time the umbilical retracts, slamming the enter key forces program 11 to run, which will reset and restart the mission timer and also reset and restart the digital event timer. So the reason you do that instead of verb 37 enter or 11 enter is because it would be really freaking hard to type all that in while the rocket's vibrating. This way, you just need to hit enter. Tape recorder, that's self-explanatory. That just records the audio in the cockpit. And that can be transmitted later via the unified S-band system's auxiliary functions on FM downlink. But that's a lot to explain, and we'll get to that later. Here we're going to isolate the glycol. If we were to abort, we would not want to send glycol to the radiators because the radiators are present, you can see, only on the service module. So if we were to abort and we didn't have that glycol isolated, we would be pissing glycol everywhere and we'd lose our coolant, which is bad. You know, we would be on the ground fast because we just didn't abort. However, if that abort happens later on, say like mode 1 Charlie, we're really high in altitude, so you could run the potential of, you know, overheating some of the electronics, which, you know, require that glycol to stay cool. So we need to bypass those so that we would have glycol level in the event of an abort. At T-minus 1 minute and 15 seconds, you're going to activate the batteries. These switches here tie batteries A and B to the main buses. Not battery C. They would tie battery C, however, battery C is actually disconnected. You can see main A, main B here, the bat C circuit breakers are open. So battery C will remain isolated from the bus. At T-minus 1 minute, you can take your pad comms to off. And the last step here is just to align your gyro display coupler by holding it down. Gyro display coupler is just the backup system for the IMU. If you get gimbal lock or lose the IMU, you've got a backup system to align the IMU or to navigate on. And that's it. That's your entire pre-launch procedure.